All right, so we're going to look at the Pacific Ocean. There's this thing called El Nino. What does that mean? And what happens? So here's a diagram of the Pacific Ocean. You can see that there's warm water, there's cold water, and there's wind blowing. So I'm going to do my best to explain the relationship of how these things move around with that diagram. Then we'll come back to the diagram and answer a few questions. Man, it is really sunny out right now. That sun hitting the ground is going to heat up the ground. So the ground starts to get hot and hot air starts to rise. Now, if that same sun was hitting the water wouldn't get as hot as fast as the ground. You got to remember, the ground has a low specific heat, it heats up fast, and that hot air starts to rise. The water has a higher specific heat, so it just doesn't get as hot as fast. It absorbs more of that energy. So there's first concept we got to remember with this El Nino thing. Hot air starts to rise and the cold air will sink and you'll start to get convection happening. Now the second thing that happens, hopefully we watched that planetary wind video from our ESRT series. I'm having a little technical difficulties, but hopefully that gets out. So the wind normally blows certain...
It's the third thing that happens, not the second thing. The third thing.
...directions, different points of the Earth. We're going to just look at a little bit of, in the Pacific Ocean, off the coast of South America and Australia, the wind is normally blowing one direction. So if the water heats up, that wind that's normally blowing one direction is going to take that warm water from the sun hitting it, and it's going to push it all in one direction. Okay? And if the wind changes direction, it will push the warm water to a different side of the ocean. So wherever that warm water is getting pushed, it's going to make these circulation patterns happen both in the water and in the air, and it's going to make a change in climate patterns. That's called El Nino, is that shift in climate patterns. So we're going to kind of bounce back and forth between some pictures where I can hopefully explain that to you, and we'll just do a couple practice questions. But the main things to look for: where's the warm water? Where is that warm water going to start the convection happening? So warm water builds up in a certain place, hot air starts to rise, and you start to get convection happening in different directions. Okay, and then where's the warm water? Where's the cold water? So where is the ocean water starting to rise? Sorry, I was just rocking Yuri to sleep. It's not so much the warm water is rising in the ocean. What's really happening is that the warm water is getting pushed, and then the cold water gets a chance to get pulled up. Because the warm water got moved one place because of the wind, the cold water gets a chance to get pulled up. Then it gets heated up and moved, and it makes that convection happen. But it's cold water getting pulled up, which is called upwelling. Okay, so here's your normal pattern. Normally the wind from South America is blowing towards Indonesia and Australia. Normally the wind is blowing from South America to the west. Okay, so what happens is this tropical region, the sun is beating down and it heats up the water, and it's pushing the warm water off the coast of Indonesia, Australia. And what happens is, since this is warm water, the warm air starts to rise, and you get a lot of storms right here in the western Pacific. And then the air circulates. This is convection. The cold air sinks, okay, and you start to get this convection pattern happening. What that makes happen is cold water from deep in the ocean gets a chance to start to rise up along the coast of South America, okay, and then the warm water builds up over here. So the cold water gets a chance to rise up. That's called upwelling. South Americans like this a lot because upwelling brings up nutrients and it's really good for fishing. So fishing happens over here. It's really good conditions for fishing normally. Okay. Now El Nino is what happens when, for some reason, not quite sure why, these winds that normally blow this way start to weaken. Since they start to weaken, you start to get wind blowing back this way and pushing the warm water more towards South America. So what happens is, instead of the storms happening here, you don't have as much warm water here. It pushes this way, and the warm water gets pushed over here, and you'll have less storms over here, less rainfall, and more of it will push towards the Pacific and the eastern Pacific Ocean. And you stop to get this upwelling. These nutrients can't rise up, and it's really bad for the fishing. And this is one of the reasons why they figured out that these long-term climate patterns were happening. So El Nino is when these trade winds weaken, okay, and the upwelling kind of stops, bad fishing conditions, and it's more spread out of the warm ocean water throughout the whole Pacific Ocean. It's not building up over here. And then the opposite of that is called La Nina. Let's shorten this video up a bit here. La Nina is stronger normal conditions, so it's the more opposite of El Nino. La Nina is just normal conditions that are stronger. I'm going to delete a bunch from this video now. Here's a few questions that you can kind of see. This is the diagram that they gave you. They said this is normal Pacific Ocean conditions. So they gave you this diagram, and they want to know during an El Nino, what is it going to look like? So what's actually happening during El Nino? And this is something that you got to know. So let's look at the normal conditions. Normally you're going to get this upwelling happening because the winds are normally pushing this way and pushing the warm water over here. And you're getting some convection like that. Now, what's the El Nino situation? These winds get weak. So two weaker winds, and which one is the weaker winds going to make happen out of here or there? Hopefully you're trying to decide, and it would be choice B. The weaker winds aren't going to push the warm water over as much, and it's going to be spread out throughout the entire Pacific Ocean. Remember, bad fishing, because the upwelling doesn't happen and those nutrients don't get brought up from deeper in the ocean. All right, so let's look at 217. This one you need your ESRT for, so we'll come back to that. 217, compared to non-El Nino years, which is this diagram, what is going to happen at the equator on the western and eastern sides of the Pacific during El Nino? So it's going to be switched. So the west, instead of it being really west, it's going to be drier. And instead of the east being drier, it's going to be a little bit wetter. So it would be choice A. So normally it's very wet here and it's drier here. Hopefully that makes sense. It comes back to Rek Shwek. Rising air makes rain. The warm water makes the air warm and it rises. There's a hidden El Nino joke somewhere in this video. Were you able to find it?